Hello guys, welcome to another session. So here in this video, we are going to discuss a crazy topic, a concept with which you will be able to solve 60% of your quantitative aptitude question. So whenever I'm talking about quants, I take a reference of CAT. So whether you're taking CSAT or SSC or any other quant exam, that's, anyway, it is automatically covered. So see, this topic, I call it as constant product rule. AB equal to C is what, I call it. So C will be a constant, A multiplied by B, which is equal to C, where C is a constant and A and B are variables, and inversely they keep varying, which means A is increasing, B will decrease. So it's widely applicable whether you're going to take speed, distance, time questions or time and work questions or price and consumption related questions, expenditure related questions, area based question, whatever you're going to take. That's what I told you. 60% of the topic, your syllabus will be covered. So let's start with I have a PPT with which I can cover it faster. So that I don't want to write too much. Okay. So let's directly go to the PPT so that it will be more helpful for you also. So as you see here, this is the topic. It's going to help you around 60% of the questions. So here, what I mean by AB equal to C is, see, there's a formula. Like it's not a formula. I never want to call it as a formula. Whenever I write AB equal to C, the C is basically a constant which won't change. So the right hand side, it's a constant, and A and B will change. A and B are variables, so it will change. It will change means, let's suppose A is increasing. Now what will happen with B? Since C is a constant, B will decrease. B have to decrease. That's when you will make right hand side as a constant, right? And vice versa. If suppose A is decreasing, what will happen with B? B will increase. So what they will ask you in questions is, A is increased by this much. What could be the reduction in B such that the C part will be constant? So that I can put it in multiple areas, this question. Okay. So here it is basically related to inverse proportionality. So when you go further, you will understand much more about its application. So just keep in mind, I'm just taking this one formula with which I'm promising you that I'm going to cover 60% of your any quantitative aptitude questions. Okay. And I'll prove with examples also. So this is what I'm looking at. As you see here, see, I can cover speed, distance, time, because speed multiplied by time is actually distance. So it's AB equal to C. So let me keep this AB equal to C, A multiplied by B equal to C. And then efficiency into time is equal to work. That is also AB equal to C. And efficiency into time is equal to work is actually speed, distance, time only. Speed multiplied by time equal to distance only. Because see, here you are just putting it as work, right? Now assume that there is a delivery boy, pizza delivery or food delivery boy or whatever it is. What is his work? He have to travel a distance. So his work is equal to distance traveled. Now, what is his efficiency? His efficiency means the speed in which he is traveling. So how fast he is traveling, that's the efficiency that he have. Now time anyway remain constant. So speed, distance, time and time and work is actually one and the same. That's why both of these are AB equal to C, right? Again, if you look at pipe and cisterns, in that questions, what you will get is rate of flow, again, time equal to volume. So now, if you see this one, efficiency and rate of flow, it is actually the same if you're talking about a motor, right? So suppose the work has to be done by the motor is to fill a tank. So the volume has to be filled. That's the work. And the rate of flow is nothing but the efficiency. And again, the time part remains the same. Similarly, length multiplied by breadth is equal to area. So all these are actually one and the same. And again, if you look at price multiplied by the quantity is equal to the expenditure. So rate of sugar multiplied by the quantity that you're consuming, that is going to be the total expenditure. So my point is, different topic, the concept is underlying, because I don't consider these all are as different topic. You may consider, the books may consider, you will see these as different chapters also. But for me, all of these comes under this one single topic or one single concept, that is AB equal to C, and that's how I cover it, right? So let's go further. Now the shortcut, the rule is very simple. I think I have missed out the rule. Okay, so cool. So this is the rule, guys. Now we have A, B equal to C. So now listen to this very carefully. A will increase, which means B have to decrease. So if A increase by this percentage, what will be the decrease in B? That's one question. Similarly, A decrease by certain percentage, what will be the increase in B? So A decrease, B increase, and connected to this I can ask so many questions, so many permutations and combinations and varieties I can make with the mix and match of this. But ultimately the understanding of this is what matters, right? So let me tell you, if A is increased by 1 by X, any, forget about A or B, anything of this, right? It could be A is increased or B is increased. So anyone is increased by 1 by X. So what will happen? So 1 by X increase in one parameter, one variable. It could be A or B. What will happen with the other? If one increase is there, certainly the other one will decrease. No doubt about that, right? So what will be the decrease here? It will be 1 by X plus 1. So something is increased by 1 by X. The other one will decrease for sure because there's an increase. And what could be the decrease? That is going to be 1 by X plus 1. Just remember this. Similarly, if the other something is decreased by 1 by X. So sometimes, see, they will ask you sugar rate was increased by certain percentage. You will reduce the consumption because your expenditure remain the same. Or they will ask you something, the rate is reduced by this much. So you will increase your consumption because your expenditure anyway remain the same, right? So something is reduced. So they will be, of course, the other side will be increased. No question about that. What is going to be the increase? 1 by X minus 1. So this is what I want you to remember. And I want you to remember only this for you to solve 60% of the quant questions, and everything that you're going to get will be the combination mix match of this particular concept only. Okay, so if you need to remember easily, if there is an increase, the other one will decrease, and if there is 1 by X, just add plus 1 in the denominator. Plus 1 in the denominator, that could be the decrease. Now if there is a decrease, no question about this, the other one will increase. No question about this. It is inversely proportional and minus 1. So if it is an increase, plus 1. If it is a decrease, minus 1. If it is an increase, the other one will decrease. If it is a decrease, the other one will increase. So I hope so far is so clear. Okay, now let's go to one simple example here. See here, as you see, what they're saying is sugar rate. Yeah, what they're saying, sugar rate is increased by 20%. So this is related to rate and consumption equal to expenditure. So the question is something like this. The sugar rate is increased by 20%, right? And what could be the reduction in consumption such that expenditure remain the same? So they're simply asking you in terms of percentage. I can give in terms of numbers also, but let's start with the basics. So sugar rate is increased by 20%. 20%, how will you write? 20 by 100, right? So 20 by 100 means 1 by 5. So 1 by 5 increase, 1 by 5 increase will lead to how much decrease? It will lead to decrease in consumption, no doubt in that, because expenditure part remain the same. I don't have, more money. So rate is increased. I have to reduce the consumption, right? So this has to be reduced. How much reduction? What I told you, 1 by X plus 1. So this is going to be 1 by 6. What is 1 by 6? It is going to be 16.66. Now, how you calculate this faster? I don't want you to divide 100 by 6. I don't want you to, because when you go further, it is going to be slightly difficult, right? It is going to be time consuming. So if I need to divide 100 and 6, I keep doing this. But instead, what I can do, what is 100 by 33? 100 by 3, 33.3. So what is 100 by 6? Half of that, 16.6. What is 100 by 12? Half of that, right? So 8.33. That's the way we need to calculate. I'll be talking about that towards the end also. So this one is very clear. Okay, so rate of sugar is increased by certain percentage. The consumption have to reduce. So this is a percentage. That's exactly what they have asked. Okay. Now assume if they are saying instead of increase, the rate of sugar is decreased by 20%, which means what? 1/5 decrease. So what will happen with the other? Other will increase. The consumption will increase. Keeping the expenditure remain the same. Okay, forget about the story of sugar and other things, but the other side remain constant. Okay, so in that case, what will happen? 1/5 minus 1, which is equal to 1/4 increase, which means 25% increase in consumption. So rate of sugar was decreased by 20%, 25% increase will be there in the consumption. Now, what they can ask you is, earlier they used to consume, let's say, the family used to consume 20 kg of rice instead of sugar, keep it rice. So 20 kg. Now, the rice, see, you may argue that rice and all these things, the consumption, whether the price is increased or decreased, these are essential items, will consume it the same. But here in quant questions, there is no logic. Whatever they're asking, you will have to reply. Okay. So this is how it is. Instead of rice, you can change something else also. If you want, you can make it as protein also. Because protein, when the price is coming down, this is not an essential item. You will start consuming more, right? That way also, meat, you can take it for example. So there is a reduction, there will be an increase. So expenditure part remain the same. So there has to be an increase. Now you are saying that earlier 20 kg was the consumption. So rather than asking what is the percentage increase in consumption, they'll ask you in terms of quantity. Earlier 20 kg. So what is the new consumption? You see 25% of 20 kg. What is that? 5. So earlier it was 20 kg. Now there will be 25% increase. So that means this is going to be 25 kilogram. Suppose earlier it was 100 kilogram. What is going to be the new consumption? It is going to be 125 kilograms. So whether they are giving in terms of number, find the percentage, convert that. Okay. So if they are asking in terms of percentage, then it is very easy. Directly you are getting it. Now let me give you one more. Okay. So this I have given to make you, easily convert this fractions. So here, as you see here, when you see 1/2, this is going to be 50%. So 1/4, 25%. Now 1/3, 33%. So 1/6, 16.6%. 1/12, 8.3%. Right? 1/24, 4.16%. That's the way you should be calculating. Now 1/4 is 25. 1/5 will be 20. So that's the way I want you to calculate, rather than keep dividing. So that won't work out also. I hope this is again very clear. Okay. One more question. So here, the question will be something like this. A train running at 4/5 of the original speed is late by 10 minutes. So they can ask you what could be the usual time. So here, what happened? The train is not running at the original speed. It is running at a reduced speed. So they'll create a story. There was an accident. It happened at this place. It happened at this distance. And I can stretch to a different level. Okay, so here, take it in this way. Something happened. So the train now running at a speed of like 4/5 of the original speed. So it's not at original speed. So if it is not at original speed and higher speed, you will reach faster. But here it is lower speed, 4/5 of the original speed, which means it is lower by 1/5. So you will take more time. How much more time it took? 10 minutes. Right? You are late by 10 minutes means it took 10 minutes more. So running slow, you take more time. That is given. So what they can ask you? They can ask you what is going to be what is the usual time? If it is traveling in the original speed, what is going to be the usual time? So there's a basic question. I can work on this and I can ask you some complicated stuff also from here, but I'll do that in the next slide. Okay. So here, what you need to do? 4/5 is what the speed now, which means there is a reduction. So they have given the reduction. What is the reduction? 1/5 is the reduction in speed. Now what will happen? The other one will increase, right? What will increase? Time. There is no doubt in that. Time will increase or not? It will increase because the distance remain the same. I have to travel from here to there. So what happened here? The speed is reduced, so the time will increase. Distance remain the same. Is that given? It is given, right? So which is given as 10 minutes. Now listen. Here, this need to be very carefully understood. So 1/5 reduction in speed will lead to how much decrease in time? 1/5 reduction. The other one will increase. Since it is reduction, -1. So this will lead to 1/4 increase in time. So 1/4 increase in time is what actually 10 minutes. So 1/4 of the original time is 10 minutes because you are 10 minutes late and you are supposed to be late by like 1/4 of original time. Correct? So original time will be 40 minutes. So if they're asking what is the usual time, it is going to be 40 minutes. Now what is this 10 minutes is all about? Your speed is reduced by 1/5. So your speed is reduced by 1/5. So your time will increase by 1/4, right? So original time is 40 minutes. What is the new time? They can ask you usual time. That's what I asked now. What the time taken in this scenario? From usual time, which is 40, you will take 10 minutes more. How you got that 10 minutes? It is already given. From the 10 minutes, you got this 40 minutes. How you got? Because 10 minutes is 1/4 of something, the usual time. So that means x divided by 4 is actually 10. I don't want to go in this way, but for you to understand, I'm just writing it. So what is x? X is 40. So x is the original time. If the train is traveling in the usual speed, it will take 40 minutes. But since the speed is reduced by 1/5, it is now going to take 50 minutes. That is why 10 minutes late. Originally 40 minutes, now extra 10 minutes, it is going to take 50 minutes. Clear? So, next one. Okay, this is slightly interesting question. Okay, so here what is actually happening? So you are traveling at 4 km per hour. Okay, and in that case, you are 20 minutes late. So I'm taking it slightly higher level now. But now if you are traveling at 6 km per hour, so when you travel at 4 km per hour, you are late. So what you do, you increase the speed, right? Suppose you are going from home to office. Okay, this is what given. So when you travel at 4 km per hour, you are 20 minutes late. So let's suppose you are supposed to reach at 10 o'clock. When you are reaching 10:20, that's what 20 minutes late. Now because of that, you increase the speed by 6 km, increase the speed, and now you're traveling at 6 km per hour. But now what is happening? You are reaching 10 minutes early. So, which means now you are reaching at 9:50, where you are supposed to reach at 10 o'clock. Story is building up, right? Now, what could be the question here? I can ask different levels of question, but out of which the most difficult question could be, what could be the distance between this? That could be the most, that could be the question that they can ask at the higher level. So here, what is happening? The speed is increased. Now, when the speed is increased, what will happen with time? Distance is same. Home to office, the distance is not going to change. So your speed is increased. What will happen with time? Time decreased. Of course, yes. Earlier you were late, but now you are early. So the time is reduced because the speed is increased. Now is what you need to understand very clearly. What's the increase in speed? 4 to 6, which is 50%. So there is a 50% increase in. So this again, if you want, I can explain how to calculate this percentage change faster. So 4, what is the factor of multiplication? 1.5. minus 1, 0.5, add 2 zeros, 50%. So this is how you will actually calculate the percentage change faster. Let's say 2 to 4. What is the factor of multiplication? 2 minus 1. You will get 1. Add to 0, 100% change. 3 to 9. What is the factor of multiplication? 3 minus 1. 2. Add 2 zeros, 200%. 3 to, let's say, 4.5. What is the factor of multiplication? 1.5 minus 1, 0.5. Add 2 zeros, 50. That's the factor. That's the percentage change. So here 4 to 6. What's the factor of multiplication? 1.5 minus 1, 0.5. Add 2 zeros, 50% change. Or it is directly, or you can calculate also otherwise, because you see the change that is 2. The change is 2, right? From 4 to 6, 2 is the change. What is the base? Base is 4. So 2 by 4 means what is the speed change? 1 by 2. 1 by 2 increase. What will be the decrease? 1 by 2 plus 1, which is 1 by 3. Decrease should be there. So speed increased from 4 to 6, which is 1 by 2. Time will reduce. It should be 1 by 3. Now, do you know what is this 1 by 3 decrease is all about? That is what given here. Is that given? Guys, look at this. Some of you may tell that it is 20 minutes. Some of you will tell that it is 10 minutes. That's not the case. Understand this example which I have given. First, assume he is supposed to reach at 10 o'clock at the office. First case, he is reaching at 10:20. Now he is reaching at 9:50. So that 20 minute he was late, that he covered. Now he is reaching 10 minutes early. Now tell me what is the exact change in time. It is not 20 minutes. It's not 10 minutes. It's actually 30 minutes. So there is a change in time of 30 minutes. So the time reduced by 30 minutes because of the increase in speed from 4 to 6. So what is the time reduction? 30 minutes. So 1 by 3 is what the reduction should be, which is 30 minutes. Now, can you find the original time just like what we did before? 3 multiplied by 30, that is going to be 90 minutes. So the usual case, that means the first case. I assume that first case is the usual case. Second case, he increased the speed, so time reduced, and the time reduced by 30 minutes, which is visible. It should be 1 by 3rd of original. So the original, which is the first case when he's traveling at 4 km per hour, which is 90. Okay, now you got two things. What's the time taken when he traveled at 4 km per hour? 90 minutes. What's the time taken when he is traveling at 6 km per hour? 60 minutes. They have not asked this. They have not asked this. They can ask both of these. What is the time taken when he traveled at 4 km per hour? They have not asked this. What is the time taken when he is traveling at 6 km per hour? That is 60. They have not asked this. What they have asked here? Cool. Right? So they have asked about the distance, which is very simple. Either this kilometer, this speed multiplied by this time, or this speed multiplied by this time. Speed into time is equal to distance, right? So either 6 multiplied by 60 by 60 or 4 multiplied by 90 by 60. So 4 multiplied by 90 by 60 means 1.5, which will be 6. Or 6 multiplied by 60 by 60 means 6 multiplied by 1, which is equal to 6. So what is the distance? Distance is 6. That's your answer. I repeat once again. From 4 to 6, there is an increase of 2 upon 4. From where? 4. Which means 1 by 2 increase in speed, which will lead to there is a reduction in time. What should be that? 1 by 3. Now, is this given? It is given from the question, right? It was 20 minutes late, now 10 minutes early, 20 minutes covered, 10 minutes gained. So this 1 by 3 reduction in time is given as 30 minutes. So what is the usual time? Usual time means in the first speed, he will be taking 90 minutes. So when you travel at 4 km per hour, he'll take 90 minutes. And when you travel at 6 km per hour, you'll take 60 minutes. They have not asked this. They have not asked this. They have asked the distance. So time multiplied by speed. So either you will go for 4 multiplied by 90. Of course, that's you need to convert into hours, which is equal to 6. Or 6, the second case, 6 multiplied by 60 by 60, which is, of course, this won't change. Distance won't change. Time change based on that speed change, or speed change based on that time change, but the distance remain the same. Now, there is one more question they can ask you. What they can ask you here is, what could be that question? One more question is the only see, any examiner ever preparing for any exam at any difficulty level, the max that he can ask us. So when he travel at 4 km per hour, he is late by 20 minutes. When he increase, he is early by 10 minutes. What should be the speed at which he should travel so that he will reach on time? Cool. Right? So how will you get that? Or what should be the time taken? Anyway, time taken, assume that you need to reach at 10 o'clock, right? So we discussed already. So suppose he need to reach at 10 o'clock. He is reaching in the first case 10:20. Second, because 20 minutes late. Second case, 9:50. So he is 10 minutes early. How much time he can take so that he will reach without being late or early? First, can you tell me that? If he's taking 90 minutes, he's 20 late, which means he can take how much time? Guys, if he's taking 90 minutes in the first case, he's 20 late. That means he can take 70 minutes so that he'll reach the office in time. Or second case you take, when he's taking 60 minutes, he's 10 early. That means again, he can take 70 minutes. So 70 minutes is what he can take so that he will reach the office without being late or early. Cool. Now, can you find the speed in which he should travel so that he will reach the office without being late or early? When he's traveling at 4 km per hour, he's late. When he increased to 6 km per hour, he's early. Now the question is, what could be the speed with which he should travel so that he won't be late or early? Simple. You got the distance, which is 6 km. Distance by time. Which time I should take? When he is taking 90 minutes, he is late, 20 minutes. When he is taking 60 minutes, he is early by 10 minutes. So what should be the denominator here? That is where your answer is. The denominator should be 70 minutes. That's the time he need to take so that he will reach the office without being 20 minutes late nor 10 minutes early. So you place here and you will get the answer. That is going to be the speed. There's the most difficult question that any examiner can ever make in any aptitude exam from this particular topic. And we done it so easily, neatly, and cheaply. Right? So I think we'll close the session. This is what we discussed, right? Yeah, cool. So first case, he's taking 90 minutes. No doubt in that. As we discussed already, I hope you understood that. Second case, that is where he is 20 late. Second case, when he increases speed, he is taking 10 minutes early. So here, 10 early. I don't want to be early. I don't want to be late. What should be the right time that he can take for the journey so that he'll reach exactly on time? If he takes 70 minutes, he'll reach on time. So what could be the speed for that? Simple. Distance you already find out, right? 6 km. How did you got that? Either 4 multiplied by 90 by 60 will give you the distance. That's the first case. Or 6 multiplied by, what is the time taken? 60 by 60 will give you same 6. Now in this case, if you need to find the speed, divide by 70. 70 by 60. So we'll get this. So it's not 4 km per hour you should travel. That's why you are late. It's not 6 kilometers per hour you should travel. That's why you are early. You should be traveling at this speed so that you will reach without being late or early. So how many questions they can ask here? First question, what's the speed in the first case? I'll mark it as S1. What is the speed in the sorry, not the speed, right? Time. Speed in the first case is given 4. Speed in the second case is given 6. So they will ask you time in the first case, 90. That's when he is late. Time in the second case, that's 60. That's when he is early. They have not asked this, but they can ask this. They have not asked this. They have not asked this. They can also ask you what should be the time that he can take so that he will reach without being late or early. So when he's taking 90, he's 20 late. When he's taking 60, he's 10 early. So from that, you can get this is 70. They have not asked this also. What they have asked? They have asked distance. Distance is speed multiplied by time. S1 multiplied by T1 or S2 multiplied by T2. So distance you can get as 6. This is what they have asked in this case. The highest level question that they can ask is speed 3. What should be the speed at which he should travel so that he won't be late or early? For that, first you find the distance, which is 6, divided by the time that he can take to travel so that he won't be late or early, which is 70. That's where you get this. So what are the question probabilities? Question number 1, first time taken. Question number 2, time taken in the second case. Question number 3, what could be the exact time he can take? Question number 4, what is the distance? Question number 5, what could be the speed in which he should travel so that he will reach on time without being late or early? Now tell me guys, beyond this, who can do it? Just with simple concept we answered. You don't want to remember too much of complicated formulas also. Cool. Okay. Now here, what we need to do, yeah, we are done with that. So now this is like a couple of tips that you can remember here in this case. So you just need to identify what is constant. For example, in speed distance time, you know that it is a distance which is constant. In case of time and work, it is a work which is constant. In case if you are, filling the tank, then the tank volume is the constant. In case if it is based on length and breadth, it is the area which is a constant. So they will ask you length is increased by, see, I told you the question, sugar rate is increased, sugar rate is decreased. Similarly, length is increased by certain percentage. What should be the decrease in breadth so that area remain constant? Same. Efficiency is increased by this much. The volume of the tank remain the same. What should be the reduction in, what will be the reduction in time? What time you can save? Same. Similar to price and consumption, similar to speed distance time, similar to time and work, similar to length and breadth. It is all same, one and the same. Okay. Yeah, it's very simple. This what anyway we have covered. So AB equal to C. I hope this is clear now. C, that right hand side is constant. A and B are varying inversely. Multiple areas you can apply. You can solve it. So once you start applying this, when you start seeing the questions, that's when you will actually understand the potential of this. So if there is an increase in one, the other will decrease. If there is an increase, it is going to be +1, which means if there is 1 by x increase, 1 by x plus 1 decrease. Now, if there is a decrease in this, there will be increase in the other. If there is a decrease, there's going to be -1. Decrease means -1, increase means +1. So 1 by x decrease means 1 by x minus 1 increase. All you need to remember is only this, and it's done. Crazy, right? Chalo, so we'll stop for the day. I see you on the next day. Thank you so much.